Hello, this is chapter 7.6, Common Logarithms. So our objectives here, so far we've simplified expressions and solved equations with properties of logs. So now we're going to solve exponential equations and inequality using common logs, and we're going to evaluate logarithm expressions using the change of base formula. So our first vocabulary is common logs. What is common logarithm? It's a logarithm with a base 10. For example, it's written, in this form. You're going to say y equals log base 10 of x. So my base is 10, and x has to be greater than 0. So this is a common logarithm. Why is that important? Well, let's see. We're going to use it to evaluate, and we're going to look at a change of base formula along with that. So example 1, it says use a calculator to evaluate each expression to the nearest tenth. Well, in your calculator, you have a log button. When you push that log button, it automatically uses the log base 10. So you don't have to put anything in, you don't have to change anything. All you do is hit, for instance, this one, you're going to hit log 5. You can put close parentheses or not. I would put close parentheses if you're doing any other function, and then hit enter, and it gives you this long number, and it says round it to the 10,000ths. Know what 10,000ths? 10,000 has 4 zeros, so it's 4 decimal places. All right, let's look at example B. It said log 0.3, so all you're going to hit is the log button on your calculator, the LOG, and then 0.3, enter, and you're going to get negative 0.52, blah, 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 blah. So just round it to 4 decimal places. Okay, so this is just, you're using common log because that's what your calculator has. And if you don't have a fancy calculator like we have, and you have just a simple scientific calculator, then those don't have, you can't hit the math button and type in whatever base you want to. So we're going to use common logs. They all use common logs if they're on your calculator as a button. Now, if you notice the common logarithm numbers, they differ by integral, which means integer, power of 10, and are closely related. So remember, a logarithm can be an exponent. So for the equation y equal log base 10 of x, y is the power to which 10 is raised when you change it to an exponent to obtain the value of x. So log base 10 of x equals y means 10 to the y equals x. So all they did was change it to exponential form to show you, look how they differ. When you have 10 as your base and you have 1 equals 10 to the 0. And when you have the argument 10, you have 10 to the 1. And so on and so on. So they're telling you, since log base 10 of 10 to the m is equal to m, it can also be equal to 10 to the m equals 10 to the m. So look at example 2. It says a loudness L in decimals of a sound is L equals 10 log 1 over m, or I over m, where I is the intensity of the sound, of course, physics problems, and m is the minimum intensity of sound detectable by the human ear. It says residents living several miles from a concert venue can hear the music at an intensity of 66.6 decibels. How many times the minimum intensity of sound detectable by the human ear was this sound, if m is defined to be 1? Okay, so how are we going to do this? So first of all, we start with our formula. So we start with our formula L. So we have L equal 10 log base I over 1, which is just I. Okay, so they give us the intensity of 66.6 decibels, so that's going to go in for L. And 10 log base 10 of I. So remember, I said write it this way because then there's no thinking about it. So we're going to divide both sides by 10. and then this has a base of 10, and we're just going to raise it. So we said I equals 10 raised to the 6.66, which I is approximately 4,570,882. It's a big number here. All right. Pause it, do guided practice 2, and let's look at example 3. Now here it says you can take the log of both sides to solve an equation. So for instance, let's just take this one. It says solve 4 to the x equal 19. So instead of changing this around to a logarithm, right, adding log, that doesn't really help us, right? So instead we take the log of both sides. And when you take the log of both sides, well, now we can use our rules. So we have our power of power rule says x times log base 10 of 4 equals log base 10 of 19, which we took the common log. That's what a common log is. Now we can divide both sides by log base 4. This just helps us so when you have a common log calculator, and then you put that into your calculator and you get, it's about approximately 2.21240, because it says round to the nearest 10 thousandths. Now, how do you check this? You can check this by graphing two equations. So our original problem was for the x equal 19. Just like the inequalities we did in class, we can say y equal 4 to the x and y equal 19. And when you put those in your calculators, you can find the intersection of the two lines, which will happen at this point here. All right? All right, so do the guided practice, and let's look at example 4. We can do the same thing when it comes to solving inequalities. So exponential inequalities. So 3 to the 5y is less than 7 to the y minus 2. Now, we said if we had the same base, we don't need to do logs. We can just simply drop the bases and make the powers a true statement. Well, they're not the same. 3 and 7, there is no way of making them the same. So what we can do is we can take the common log of both sides. Then we've got 5y log base 3 is less than y minus 2 log base 10 of 7, right? So all I did was use my properties of power of logs. So now I'm going to distribute this. I have two terms, right? Right here times log base 7. So I have y log base 10 of 7 minus 2 log base 10 of 7 is less than 5y log base 3. Okay, so all I did was I took this log here and I distributed multiplication. I can do that. So now I'm solving for y. So I'm going to move this to the other side. So I'm going to subtract y log base 10 of 7 from both sides. Okay, they're not equal terms, so I just have two terms. 5y log base 3 minus y log base 10 of 7 is less than negative 2 log base 10 of 7. I'm just using algebra. I just have crazy terms, that's all. So now I'm going to factor out a y. So 5 log base 10 of 3 minus log base 10 of 7 is less than negative 2 log base 10 of 7, and then we divide everything by 5 log base 3 minus log base 10 of 7. So, and we can put that into our calculator. We can put this because they're common logarithms, right? And we get an answer of y is less than negative 1.0972. So I can check it. I can test y equals -2, right? Because it's in that range, it's less than this. So if I put y equals -2, when I put it in here, I'm going to end up with a true statement of 1/59049 is less than 1/2401. All I did was put this value back into the original equation before I added the logs, and then checked it. All right, so do the guided practice, and let's look at the last thing, which is called the change of base formula. Now, the change of base formula says that if you have a, b, and n are positive numbers and a and b can equal to 1, when you have a log base a of n, it equals to the log base b of n divided by the log base b of a. So if you have a scientific calculator or regular calculator and you don't have a fancy calculator, you can put it in. This is called a change of base. Now on the test, you will have to do this and show your work. So we normally change this to a common log, but it doesn't matter. So if I have log 3 of 11, or if you have an older calculator and you're having a hard time punching this in, well, you can change this to common log of 11 divided by the common log of 3. You see, because I don't have anything written here, it's an implied 10 or an implied common log as the base. Now you can put this in your calculator and evaluate it. All right, so let's look at example 5, where you're going to change the base of formula. So we have log base 3 of 20. They want us to use the change of base formula and then round to the nearest tenth. So this is going to be the common log of 20 divided by the common log of 3. Now we can put our calculator and we get it's approximately 2.7268 is our answer. So we can do this at ease, especially with you guys with older calculators, but you still have to know how to write it. So if I ask you to do this on the test or a quiz, you must show your work and then put it in your calculator. If you just go from here to here, it will be wrong. All right, you got to show your work that it's a common log. All right, pause this and we'll see you in class.